Welcome to Science, everybody. We're going to look at the Temperature Range Lab today. To do so, I used to live in Minneapolis, Minnesota, right here on the map. And as you might guess, it was really, really cold there in the wintertime. And really cold the whole entire time, like from Thanksgiving through St. Patty's Day at least would be frozen entirely. Um, the ice on the ponds and lakes would get to be like easily 3 foot thick. Um, it was cold, 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 outrageously cold. But what you might not guess is that also when we got to summertime, it was really hot. And that's what the premise of this lab is going to be, is thinking about this difference between the hottest time of the year and the coldest time of the year. I don't necessarily want to think about warmer or colder. Ideas to ignore today are warmer and colder. If you're telling me that, oh, this city's hotter, you're missing the point of today. What we want to look at is the range of temperatures for that city. This little graph right here on the bottom left, oops, sorry, is back when we were talking about tides, because range was an important idea back then too. We talked about neap tides having a small range where the high doesn't go as high and the low doesn't go as low, and spring tides having a very high range where the high tide comes way up and the low tide goes way down. It's the same idea. Back then, we didn't want to say the tides are higher because that's missing the point. In spring tides, yes, the high tides are higher, but the low tides are lower. It's more about that difference from high to low. That's the range idea we're looking for today. And what's going to be important with that is that we're going to be comparing cities on the same latitude, which, if you were tuned in during seasons, the idea with two cities being on the same latitude, basically left, right of each other, east, west of each other, is that they'd be receiving the same amount of sunlight throughout the course of the year. Now, if I were to compare Pulaski to Orlando, yes, you can generally say that Orlando is warmer because Orlando's further to the south or closer to the equator. They get more sunlight, they're warmer, or vice versa. Pulaski is colder, they're closer to the North Pole, right? They get less sunlight, they're going to be colder. That's not the idea today. The idea today is let's take two cities that get exactly the same amount of insolation, sunlight, incoming solar radiation, and compare their temperature ranges. With the trick being one's going to be near the coast, one's going to be next to the ocean, and one is going to be over here in the middle of the continents. Okay. It's really picking up with the same ideas that you guys did in your sand versus water lab. I know this drawing's ridiculous, but you did two beakers, one filled with sand, one filled with water. We put a light on it. We let it heat up for 15 minutes, and then we let it radiate for 15 minutes, and we saw what happened. And if you didn't finish that, some of you still owe me that, but spoiler alert, the sand heated up more and cooled down more. So the sand went way up and way down. The water went up a little bit and then down a little bit. And again, I know I brought this analogy up before. If you've been to the beach, same idea. You get out of the car or the boat and you go onto the sand, and as it's been out in the sun, it gets very, very hot. So for relief, you go running over to the water, put your feet in the water. It would be very strange, a very strange reality if the water were as hot as the sand were there, right? We all know it's not. And that idea is tied in with this lab. And maybe the idea of specific heat as well. Okay, this lab brings a lot together. This is a more thinky lab. If you remember, water has a very high specific heats, and what that is how much energy it takes to heat a gram by a degree Celsius. So liquid water takes the most out of all the other substances. Sand directly is not here, but some of the stuff that makes up sand would all be down here with lower specific heats. So equal amount of energy going in means that the dry sand is going to go up by more because it takes less energy to heat it. Okay, that's a review from all of the absorption radiation stuff, and hopefully we can get that to make some sense. So again, if we were like, this is basically what the lab is. This is how different is the temperature from July to January, and then you can see closer to the ocean, further from the ocean, what happens. And again, if you say warm or cold for a city, you're missing the points. Here we want to think about a large range for the red line versus a smaller range for the blue line. Okay, so let's take a look at the lab. Why not? If we take a look at two cities on the same latitudes, since they're on the same latitude, the amount of insolation should be the same. Plug that in there. That means they're getting the same duration, the same amount of time of sunlight. They're getting the same angle, it's therefore the same intensity of sunlight. If they're on exactly the same latitude, everything with the sun is exactly the same experience. So you're going to pick two cities. Actually, we're going to figure out a way for you to get assigned two cities. Look to the survival guide for that. I'll get to that on there. One will be coastal, near the coast, therefore near water, and we know that water has a high specific heat. And one will be continental, far from the water. You go to this website, I'll give you a better link on this survival guide because I know that the links on these PDFs are sometimes a little fickle. Once you go there, it's a very easy to use website. You plug in the city. There is one small trick here. Here's what that website looks like. People in general have had an easier time clicking through. Oh no, ads. That's new. Clicking through and going like by this, you can try to search, but if this has been kind of fickle in the past, especially if you misspell it, it doesn't do you much good. So go to Minnesota and go to whatever you get assigned, Minneapolis. One of you might get that. And there you go. It's just this top row. Don't worry about all this stuff. I know this looks like a lot of data. What's the temperature? Don't worry about annual even. In January, that's the temperature. In February, that's the temperature. In March, that's the temperature, and so on. Give me those 12 right in these boxes right here. Just make sure that you do the coastal one on the coastal, the continental one on the continental, and you'll be good. Okay. Let's steal one January number, 15.6. So that would be what goes in here if you get Minneapolis. Okay. Down here, we'll do the months, January, February, March, and so on. And then when it comes time to plot, January would be 15.6. So January, 15.6. Remember, if you make these dots a little bit bigger, it just makes life easier. Right about there. I would color code it so you'll have one line that's blue. So we'll say these are blue. I don't know, whatever colors you choose, doesn't matter. Those are green. Then you'll have two line graphs, and then we'll look at which ones have the higher and lower ranges. Tell me what ranges. A lot of times people skip this question for some reason on this lab. Don't do that. It's there. They just get right to plugging in data, which is great, but just don't skip this question. Run the numbers, subtract to give me the ranges, and we'll be good. I just wanted to bring up real quick rate of change problems. We've done them before, but just to see it one more time, it is, and it's on the slideshow. Change in value divided by time. So how much did the temperature change divided by how much did the time change? So this says you go from January to July. So you'll just divide, count the months, January, February, blah, 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 to July. That's that many months divided by basically this number. How much was it from the coldest to the warmest? And then a bunch of regions questions to see how we're doing. All right. Again, not to overstate it, warmer, colder, going to be wrong. Give me large range versus small range. I wish you luck. I'll be here if you have any questions. And we'll pause this thing. Thank you. Good luck.